Welcome back to our series of liaison discussions. We're joined now by Giorgio Ascoldi. He's the NITRC liaison for the computational neuroscience domain at NITRC. Tell me, Giorgio, why is making more information about computational neuroscience tools and resources important to the community?
Hey, David. So I like to think of neuroscience as a still relatively young field, and yet it's very different from how it started. So the old notion of kind of scientists in silos, isolated and doing their own pioneering experiences is really a thing of the past at this point. And today we're actually all part of a large, global distributed operation. With literally thousands of labs across the world running new experiments all the times. And ideas flow very fast, right? So tens of thousands of people gather at conferences, papers go up in preprints that can be seen instantaneously all across the world with a browser. So the ideas flow fast, and so do the results. But how about the data and the models, right? So in a certain way, I like to think of simulations and computational models really are as the true, complete, reproducible definition of concepts and hypotheses, right? Because you're really defining your idea down to parameter values, and you can implement it in a computer. So it's kind of self-contained. So the notion is simple. Simulations live in the world of bits and should be just as fast as ideas to move. And so that requires resources and tools and models themselves to be findable, accessible, and reproducible. And I think that's where resources like NITRC come in to provide the connectors across the community. So I think that information sharing, especially in the field of computational neuroscience, really means community building in this sense and acceleration of progress.
Cool. Can you say a little bit how the sort of macroscopic neuroimaging types of things, the MRI and the PET and CT, interface with the modeling, sort of the neural types of things? Do you have any insights on that?
Yeah, absolutely. Well, so first off, there is modeling done at all scales, including the whole brain fMRI and so forth. And that's quite a different scale from, let's say, the microcircuit when you start talking about neurons and synapses, even though conceptually, of course, one is made out of the other, right? So it's a matter of zooming in and zooming out. But it's interesting that basically the small unit of observation and also of computation of the whole human brain level, let's say the voxel, the fMRI voxel, it's just about about the same size as the largest possible micro models that we're building, both in terms of computations and experimental constraints. So the kind of people are trying to push the limit, for example, of electron microscopy and reconstruct tissues and then model them. And I think that we're pushing towards getting to about that fraction of cubic millimeter, which is now the forefront of high resolution imaging. So you can have models directly at the level of whole brain imaging, but also you can have models at the smaller scale in terms of neurons, network circuits. And ultimately, it would be nice to have multi-scale models, right? So you're able to capture the entirety of the brain and its dynamics and its emergent properties with at least some aspects defined all the way down to the level of mechanisms, cellular, and why not also molecular.
So NITRC can help be a conduit from the people who often think in these imaging spatial domains as a conduit to some of the stuff at that smaller domain, but also the other way. There's the resources, the hosting, the content at NITRC has an opportunity to flow up to the bigger spatial scales of the imaging.
Indeed. And I think that scale is only one such dimension that NITRC serves as a bridge between. So I think that there are also a matter of focus, for example, and you see that within imaging, and you see that at the smaller size. So for example, you can think in terms of anatomy or architecture, you can think in terms of physiology or dynamics, and you can think in terms of, for example, genetics and development, right? And you see those at the level of whole brain level, and you see that level of neuronal modeling. And then again, there are also aspects of, even if you think about computational modeling, what really that term means. I think that the meaning of the term has changed over time. It started maybe as just standard compartmental models, Hodgkin-Huxley compartmental models of neuronal biophysics, or perhaps, mathematical equations describing, theoretically optimal network dynamics. And these days we see computational neuroscience being used for describing work that is really machine learning and data mining, or database, curation and infrastructures and metadata, and all the way to really neuromorphic engineering, right? So I think all of these aspects are currently represented in NITRIC.
From the NITRIC resource point of view, what types of things count as computational resources that NITRIC should have in its portfolio?
Well, I would start with the obvious. I would say clearly simulation environments, so software codes and scripts and tool executables are, in a way, by definitions, part of what counts if we say tools and resources, because those are the tools. My own perspective on this is to cast the net fairly wide. So I think that obviously model definitions themselves, but also digital data that could be used to constrain or validate a computational model, in my opinion, that counts too, right? So and then you realize, it almost becomes all of neuroscience, right? Because almost any data. But I would say at least data that are digital, they're represented as digital data, as bits, as opposed to say tissue and antibodies and so forth. I would say those are fair game to be considered highly relevant to computational neuroscience.
Great. And in addition to data and software, are there other sort of knowledge environments or community discussion groups or other types of more human-human types of things that you can think of?
That's great. It's so sometimes it's really the tools and the data that once you put them out there, they kind of catalyze a growth of a community around it. I like to think of that as an ecosystem where you have many actors and interactions, and the various elements that gather around the data and the resources work synergistically. So for sure, working groups and generally speaking, small sub-communities, let's say, that work with data and with models do come together. And I think that NITRIC, in fact, has catalyzed. I have experience of actually colleagues telling me that after posting their resources or tools on NITRIC, they actually saw, say, a mailing list, the group user lists, posting questions and eventually posting answers. And it kind of took a life of their own, and occasionally the resource owners check it out and find a sub-community live and kicking that emerged out of that availability.
So I guess summarizing that, NITRIC is a place for people to discover these ecosystems, and NITRIC is a place where people can help build those ecosystems if they don't exist or if they're needed. That's great.
Yeah.
Can one find many computational neuroscience data sets themselves at NITRIC?
Yes, and growing, I would say. So computational neuroscience was not there from the get-go in NITRIC, so it's been kind of a late addition, but I think also a strategic addition given the increasing role that computational neuroscience is having in the field. And there are definitely more and more that have been added, and more are actually now added spontaneously. So at the beginning, we seeded some core content by looking at very well-used tools that we felt had to be there and were representative of the communities. And I think now more and more, both resource owners as well as users are requesting additions into NITRIC, which is also happening. So it's a good number now, and I think it's continuously growing.
And I guess it's important to note that some of that content might live at NITRIC, or some of that content might live somewhere else, but NITRIC can be a clearinghouse, a catalyst to identify and go to wherever that content happens to live, even if it doesn't live at NITRIC.
Indeed.
So I'm sure you're aware of the computational environment, the NITRIC CE functionality they run. Are there computational neuroscience tools that operate in the NITRIC CE environment?
Yes, there are. So I can speak in anecdotally, at least in my first-person perspective here. So I can tell you two brief stories on this. The first one is part of a large international consortium called Big Neuron, which endeavors to provide a resource to reconstruct neurons in a very distributed ways from data in varieties of formats, and using a combination of algorithms and human annotations. And this has been something that has been working in the communities for now several years, over 5 years. And we arrived at a point where we had a very large amount of data and a lot of interest from the community, and we need a place to put it. But it was really a distributed collaboration. There was no single lab or PI that was in charge of this. It was more like a group of interested PIs. And we were actually physically located in 4 different continents, right? So US, Asia, Australia, and Europe. So, you know, so who gets to host the data? There is both the cost and the visibility opportunity, if you like, and so forth, as well as, of course, responsibility for backups and bandwidth and so forth. So I thought that perhaps NITRIC could help with that as an international neutral broker, which was non-profit and kind of above the parochial interests and so forth. And indeed, you were very kind to help, and it's now in the process of being set up for both a data hosting service as well as a computational hosting service. Which will allow users around the world to access the data and compute on them without moving the data, right? So computing directly where the data are, which is quite important. So that's the first anecdotal story. The second anecdotal story is actually almost serendipitous. I have a family member who is in college right now and planning to go into grad school, and was looking for opportunities for research internships to decide exactly to refine what to do. And this person is not a neuroscientist, is actually a computer scientist, and ended up matching in a very well-known prestigious lab in out there high up institution working on brain imaging. And of course, having a relative working on neuroscience and not realizing that, there are many types of neuroscientists, this person came to me and say, hey, they are, they have a pipeline to work on fMRI data, and they have a MATLAB script that does support vector machine data analysis on this. And notice, all of these were completely jargon terms to me, right? I do not work with fMRI myself. I do not do support vector machine, data analysis myself. And yeah, I know what MATLAB is. I'll, grant you that. And this person wanted to go to this interview well prepared because he knew that one of the interests was, we need to pour this into Python and do a good job at it, and they need a computer scientist for that. And while on the phone, right, what do? I just pop up my Chrome browser and I go nitric.org, and I just plug in fMRI, support vector machine, Python. As simple as that. Now, try to do that on Google. It will not work, right? But you do that on NITRIC, came out with 5 tools. Actually, it ends up 4 out of 5 were relevant. And at least one that I understand, actually works on NITRIC CE. And I just sent the link, and this person was incredibly grateful. Not only was this person able to nail the interview and impress his future supervisors, but also he actually made it his own and said, hey guys, you guys work in fMRI, you should know this NITRIC thing. And they were blown away by the fact that, this was a really good resource to consolidate a lot of knowledge in the community. So that's to say that there are some practical applications and nothing better than trying it out.
Oh, those are great stories. Thank you for sharing those. So if I was a developer of some new computational neuroscience resource, what do you recommend that I do?
Well, the simple and short answer is add it to NITRIC. It's an incredibly quick and easy process. And you can start simple, just add the name and simple descriptor of the resource, a link. And if you need a space to upload it, just go ahead and upload it. But if you just want to link it to an external thing, you can do that. And at least in my experience, very soon you'll start getting hits and traffic to your resource through Nitric. But also in a very nice way, you'll be able to point your prospective users to Nitric, and in many cases to services that, simple services that Nitric actually offers once you register your tool, including, say, frequently asked questions that you get access to as simple clicks. And as I mentioned, even setting up, say, user mailing list if you don't have that. And one thing that I noticed that I didn't realize was there, but I noticed it with my own resources as I point users to them when they email me about those, is that there is even a service that now browses the literature and checks citations to the use of those tools. And that's really cool, because now when I submit my yearly grant reports and I have to not only count with the beans of what papers my students and postdocs have published, but I always go check there and say, look, there are these other 20 papers that use my tools, and I don't need to bother searching for myself, and Nitric is doing that for me. So that was the slightly longer answer, but in short is add it to Nitric. It's simple and you'll get a lot of bang for your buck.
Great. I'm glad you mentioned that resource, the literature, scraping resource, and for completeness, we echo that information, but that source of that data is actually coming from SciCrunch, our friends at UCSD, and the RRID concepts mine that. But then Nitric collaborates with SciCrunch and helps present that information in yet another place, in addition to the SciCrunch portal, which you might not go to as often as the Nitric portal.
But David, can I comment on that? Because this is actually a very good point. The user in many ways doesn't need to understand what's going on under the hood, right? So the beauty of a place like Nitric is that it's a warehousing service, right? So you get a lot of services, data, and links from different places. But the key is that then it's a one-stop shop where a user can come, search, and find what they need, independent of what sources they've been collated from.
Yes, and that's a great point. And the more things, like the SciCrunch or like other engines that generate, similar things, we at Nitric are super happy to help present those to the community in a nice tool-centric or forum-centric context. So in general, are there anything else you'd like folks to know about the computational neuroscience domain at Nitric?
I would say try it out, give it a test run. I would say, I'm optimistic that you'll be positively surprised by what you find, but don't be shy. This is a community resource. As such, if there is something you don't like, or if there is something you'd expect to see there, you're not seeing there, shout, right? Just provide feedback. And there's actually a very easy button to provide feedback there. And you can say, hey, I can't believe that this resource is not there. And in fact, the Nitric staff and the liaison like myself are there exactly for that. And the chances are within a couple of weeks, you'll find that resource in there if you try again.
Great. So thank you for taking a moment to talk about the computational neuroscience domain, and thank you for your service to helping manage that portfolio of resources.
My pleasure, David. Keep up the great work.
Thank you.